So, hello friends. In this video, we are going to discuss a Leetcode problem of the day, merge nodes in between zeros. So, basically, what the problem statement says, let's see that you are given in the head of the linked list, okay, which contains a integer separated by zeros. So, basically, we have been given the head of the linked list, okay. In this head, so this is the head of the linked list. Basically, here the linked list of the head of the linked list is given here. Okay, and this is separated by the zeros, the beginning and the end of the linked list. Means the beginning contains the zero and the end of the linked list contains the zero. Okay, so now basically, hey, for every two consecutive zeros, merge all the nodes lying in between them into single node, whose value is the sum of all the merged nodes. The modified list should not contain any zeros. So we have been given zeros in this problem statement. So we have to find the sum of the numbers in between the consecutive zeros. Okay, in between the consecutive zeros. So this will give us 4 and this will give us 4 plus 5 plus 2 is 11. We have to return the head of the modified linked list means this will be the head. Okay, we have to just find the sum of the numbers. Our next is 0 1 0 3 0 Okay, we have to find the sum of the numbers in between the two consecutive zeros, this and this. So it will result in 1, this will give 3 as our answer and this will give 4 as our answer. So our new head will be 1, 3 and 4. Okay. So basically how is this, how we are doing this? Means how is this possible? Okay. So we are creating a dummy node here. Okay. We are creating a dummy node. Okay, that will ultimately act as a predecessor of our new list. We will initialize tail to also refer to this dummy node. Okay, let's try to understand it with the help of an example. Yes, so this is our example 0 1 2 3 0 4 5 0. Okay, so let's see what is the output of this. Yes, our output is basically 0 6 9 0. Okay, so basically this is going to be our output. So how come we can find this? Yes, we start by creating a dummy node. We start by creating a dummy node. Okay, and making both the dummy and tail point to it. For example, we will start from 0. As we know, we will start from 0. Okay, so this is our dummy, and our dummy will point towards the tail. Okay, our dummy will point towards the tail, and it will start from what? It will start from 0. As you can see. Okay, so our running sum, we will find the sum here. So our running sum is what equals to 0. Okay, as you can see, our running sum is equals to 0. Now we initialize our dummy and tail nodes. Okay, then we will initialize the running sum to 0 and set the current to head dot next. Means to skip the initial node. Means the initial 0 head dot next. This is basically our head dot next. It will skip the zeros. Okay, as you can see here. Okay, the head dot next will skip the initial zeros. So we iterate through the list, updating the running sum and creating new nodes as we encounter the zeros. Okay, first of all, let's see our list. Okay, so first of all, our current sum will be what? First of all, it will be equals to 1. Okay. Then our current sum will move to the next node. Our current sum here, it will be equals to 1. Okay, then our current sum will be what? It will be equals to 3. Okay, 1 plus 2 equals to 3. Then our current sum it will be equals to 6. Okay, as you can see here, then the 0 comes. Okay, our current, so now our current points to 0. So we reached the end of the sequence. Means we have created the new node with value s, which is 6. So we will attach it to tail dot next. Okay, we will attach it to tail dot next. Means it will means and update the tail to point to the next node. Okay, now now our dummy is equals to what? This is our dummy. First it was equals to 0. Now it is equals to 6. Okay, and now this tail, it will point to the tail. Okay, now we reset s to 0. We will reset our sum to 0, and it and move the current to the next node, means 4, and repeat the process. Okay, this process, and now we will repeat the process again. This will give us s equals to 4, and this will give us s equals to 9. So now our current points to 0 again. So this is the end of the sequence, and then we will create a new node with value 9, and it will attach it to the tail and update tail and reset. Okay, so now our new tail will be this. Okay, now we have got our new sum as 9. As you know, our new sum is 9, so it will now again point it to the tail and move forward. Means tail dot next. Since there are no more nodes after the final 0, we have finished iterating to the list. So our list is ready, and we will return to dummy dot next. So our list is ready. So this is our list, and it is now ready. So our 9 will point to again 0. Okay, so our resulting list is this, and now we will what do? We will do our dummy dot next. Okay, this will print us the new head. Okay, and 6, 9. So now let's try to see the code implementation. This was the explanation. Okay. So this was the explanation of the question. So now let's try to implement it with the help of the code. I will use the both kinds of both C++ and Python approach. Okay. So now let's start our question. So this is our Python, and as you know that this will be is going to our C++. Okay. So basically in Python and C++, what's the difference? The difference is just a simple one. Yes. So the difference is just a simple one. In Python, we use the simple dot. Okay, self dot val equals to val and self dot next equals to next. But in C++, we use the arrows. Arrows like this. Okay, to point towards the next or the value. Okay. So now let's start with the Python. Basically, first of all, what we will do, we will create a dummy node, which will be the placeholder for new list start. Okay, let's begin. Dummy node equals to what? We'll initialize it to the tail. Dummy node is initialized to the tail, and now we will initialize it to the list node. Okay, now we will initialize our node sum. Our node sum equals to 0. Then we will initialize our current node to head dot next. Means this will move the cursor to the next node as we want to skip the initial 0 mode. Okay, this will move the cursor. So now we will use the while loop. While current node means it will run till the current node is running, means the cursor is pointing. Now we will check if our current node is not equals to 0, means if it is not equals to 0, so our node sum will be incrementing. Our node sum will be go on incrementing with the current node value, means the value of the current node. Okay, then if we encounter a 0, means if we get a 0 at the end of the list. Okay, so else if we get a 0, what we will do, we will initialize the tail dot next. Means if a 0 node is encounter, so this signals the end of the segment. Okay, so we then add a new node. Okay, with the segment sum to the resultant list. So we will initialize the tail dot next to the list node and of node sum. As you can see that I have initialized the dummy node to list node, and now I am initializing the tail dot next to the list node of sum. Okay, now we will initialize our tail to tail dot next. Okay, and now we will reset our node sum to 0. As we know, as we initialize it to 0, we will start from the new zeros, new nodes. Okay, now we will move to the next node in the original list. Okay, So our current node will be equals to current node dot next. Means we will as we will stop at the zeros, then we will move on to the next nodes. We will calculate the sum of their values. Okay. Now what we will do? We will return the dummy node dot next. Means the new dummy node. We will return the dummy node dot next. Okay, means we are returning the new dummy node, means a new list with the initial dummy values, means the dummy nodes. Let's try to run it. Yeah, it's giving some runtime error. Okay. As you can see that the cell we have been given cell dot val. Okay, but we are using the value here. We are using value. So let's make it to val. Current dot not sum list dot val. And I have made one mistake here. If our current node value means the value of our current node is not equals to 0, then we will increment our node sum. Let's try to run it now. Yeah, it's being accepted. Let's try to submit it. Yeah, it's being accepted and runtime is 956 meter second and it's faster than the 54.10. Okay, it's giving some better runtime. So the time complexity of this problem is what? The time complexity of this problem is basically O of n, where n is the number of nodes in the linked list. This is because the code iterates to the each node. Okay, now let's see the Python approach. Yes. As we have seen the Python approach, now let's see the C++ approach. Sorry. So basically, what's the difference in the Python and C++ in this topic of the linked list? It's just a simple thing and nothing else. Okay. First of all, we will initialize the dummy node. Okay. As we have initialized in line number 8 in Python. Okay. So we have created a new function here, new list node, empty list node. Okay. Then we will initialize the tail to the dummy as we have done in the Python. Line number 8, we'll initialize the tail to the dummy. List node tail equals to dummy as you are able to see here. So now we will initialize our sum, current node sum. Okay, our node sum to 0. In sum, in node sum equals to 0. We have initialized our node sum to 0. Then we will iterate over the node starting after the first dummy. Okay, we will run a for loop here, iterate here. For list node. We'll initialize our current to head dot next. We'll initialize the current to the head dot next. Okay, as we have done in line number 12. As we have done in line number 12 in Python, we have initialized the current to head dot next, current node. Let's make it more easier, current node, and make it a dummy node. Make it same as the Python dummy node, current node. Okay, node sum, current node. Huh. So we have initialized it to the head dot next. Okay, means it will go forward till the null pointer. Okay, so if our current node is not equals to null pointer, null ptr, okay, null pointer means, as you can see in the line number 6 of C++ code, we have been given list node int x, its value and next to the null ptr, null pointer. So that's why we have added it in the for loop. And now we will initialize our current node to current node not next. Okay, means we have initialized our current node to what current node equals to current node dot next. Okay, we have made it to next. As you can see here, yes. Now we will curly braces. We will add curly braces. So as you can see here in the C++ code, the line number 19, I have initialized the current node to current node dot next. This is equivalent to the Python line number 22. Means our current node will be increasing. Means it will be going forward node by node till it encounters a zero. Okay. So this is done. Now we will iterate to the for loop. Now we will check if our current node dot value is not equals to zero. If our current node not val is not equals to zero. Okay, if it is not equals to zero, we will increment the node sum by current node not val. We'll increment the node sum by the current node's value. Okay, its equivalent value. So this line number 21 is equivalent to the if statement of line number 15 and 16 of Python code. Okay, as you can see, there is a no difference. There is no difference in the C++ and Python, just some basic syntaxes and nothing else. Now, if a zero node is reached, you will add a new node, okay, with the accumulated sum to the result. So, we will initialize the tail, next tail to new list node and initialize the node sum in it. As we have initialized the node sum. So, this line number 23, this tail dot next equals to next node is equivalent to the else statement of the Python. Okay, as you can see. So now I am initialize the tail to tail dot next. Okay, and reset the node sum to zero. And I am resetting the node sum to zero. Okay, now we will return the dummy node dot next. Uh, yes, now we will return the dummy node dot next. Okay, as you can see, the Python code is fully equivalent to the C++ code. Okay, just a basic syntax difference is there. Okay, we have been given error list node dot star. Okay, where is list node dot star? Hmm. In the for loop, line number 19, number reference is a pointer. Did you use? Okay, there was a error here. I need to use it arrow. Okay. Listen, friends. In Python we use a simple dot, but in C++ we for pointing towards the node or the equivalent value we use the uh, arrows. Okay. So now let's try to submit it. Yeah, our code is being accepted here, as you can see. Yes. So thank you, friends. If you have any of the doubt, you can ask me in the comment section. Okay.